This presentation is a summary of work that has been completed on the Obelisk deposit in the North Paterson Orogen. The Paterson Orogen is located in the northern part of Western Australia. It's located along the boundary of the Pilbara Craton and towards the northeast of the Duuring Craton. Obelisk is located in the northern part of the Orogen. GSWA's goals are to support and promote mineral exploration in the Paterson Orogen. And to do this, we arranged a collaborative research agreement with SEPA Resources. And the agreement was to scan drill holes through the Obelisk deposit, PND 001 to 004. The work was funded by GSWA, provided that all data were to be publicly released. And it included the donation of one drill hole, which is drill hole number 2. A fifth drill hole, PND 005, was drilled earlier, part of the exploration incentive scheme. And both drill holes are presently stored at the Perth Core Library. Obelisk is a gold, copper, tungsten target. It's hosted by metamorphosed Proterozoic basement rocks, which are overlain by Phanerozoic rocks or the Canning Basin, and these basin sediments are draped by quaternary sand dunes. And the depth to metamorphosed basements is 70 to 150 metres in the Obelisk area. The local geology is interpreted from geophysical data, and it's interpreted to include metasedimentary rocks, granites, dolerite and gabbros. And the metamorphic grade of the rocks at Obelisk are amphibolite facies. On the left-hand side is a simplified diagram of one drill hole, PND 002. It shows the distribution of rock types. The earliest rock type is metasedimentary rocks, which are metasamite and in blue and metapelite in yellow. And they're shown in the photos on the right-hand side. The metasamite has a granular texture, whereas the metapelite contains more micas and has a schistose texture with round porphyroblast or cordierite. The metasedimentary rocks have been intruded by metagabbro in green. And this photograph shows the echogranular metagabbro, but also an unusual part of this rock, which is the leucosome, and this is zircon rich. These rocks are variably mineralized, and they are cut by two post-mineralization dikes. The earliest one is a pyroxene dolerite in purple, and the second one is a granitic pegmatite, shown on the right-hand side. I also indicate which rocks have been sampled for geochronology, and they include post-mineralization rocks and pre-mineralization rocks. The metamorphic facies is probably amphibolite facies, and that's determined from the presence of cordierite in the metapelite and garnets, and these porphyroblasts are wrapped by micas. Both the metasamite and the metagabbro are also metamorphosed to amphibolite facies, whereas it's a bit unclear at this stage whether the dolerite and pegmatites are metamorphosed. Thin section work will resolve that question. The metasedimentary rocks and metagabbro are altered, and in this diagram here I show the results of the spectral scanning with the high logger, the shortwave infrared data and the minerals that are interpreted, and the thermal infrared minerals with their legends down the bottom, and I show in a qualitative sense the distribution of altered rocks. The earliest alteration phase is a higher temperature, and that's really defined by the presence of biotite quartz alteration with sulfides in the metasamite and metagabbro. This is a photograph of the metasamite, and that's a photograph of the gabbro, and you can see the disseminated pyrite and pyrrhotite in these rocks. The mineralization is located along the contact between the metasedimentary rocks and the gabbro, and it's structurally controlled with extensional and shear grey quartz veins occurring where the disseminated alteration is. And the alteration replaces the pervasive fabric in the area. A second generation of alteration overprints the earlier hotter temperature one, and the second one is defined by chlorite and sulfides. And these are semi-massive sulfides shown in the photographs here, piercement textures cutting the wall rock, and where they interact with the earlier quartz veins, they cause the local replacement or granulation of the quartz veins. The timing of the dikes are shown in these photographs here. In the first one, it clearly shows the later timing of the granitic pegmatite, which cuts this darker pyroxene dolerite. The pyroxene dolerite is post-mineralization because it cuts mineralized and altered metasedimentary and metagabbro wall rocks. And the pegmatites are clearly post-mineralization because you can see how a quartz-rich vein is cut by the pegmatite. And these post-mineralization dikes cut alteration in the pervasive fabric, but locally you can see folding of the pegmatite, and this indicates that there's a second folding event with local development of an axial planar foliation in the pegmatite. Summarized here in this sketch, the first event is the formation of metasedimentary rocks in blue, which are intruded by the gabbro. Folding of this contact and these rocks formed a pervasive foliation, which is the SN, and that dips deeply to the southwest. Mineralized quartz veins occur within both rock types as shear veins. Dolerite dikes cut the gabbro and sedimentary rocks, and they are in turn cut by the pegmatite. Later folding resulted in folding of all these rock types, including the shear veins. Further work at Obelisk includes interpretation of thin sections, both of proliths and alteration zones, plus interpretation of whole rock geochemical data, so I can characterize the least altered rocks and compare them with their altered variants. And lastly, geochronology, based on dating the pre-mineralized rocks, the post-mineralized rocks, and also dating mineralization directly through molybdenite or xenotime and monazite associated with ore zones. Further work elsewhere in the Paterson includes looking at the Citadel deposit, the Venus deposit located to the north of Obelisk, and looking at other examples throughout the Orogen. We're interested in the protoliths, their age and their chemistry, signs of mineralization to be used as pathfinders for exploration. On the right-hand side here are some of the drill holes that we are interested in, colored by their level of scanning with a high logger. The red dots indicate they are diamond drill holes that have not been scanned. The yellow ones indicate holes that have been scanned to level 1 processing, whereas the purple have been scanned to a high level of interpretation. Lastly, if you want more information, you may go to GeoView. You can see these 5 drill holes spatially. If you click on one of them, a pop-up will occur and you'll have the chance to download the spectral data and also some of these high logger records. And on the right-hand side is an example of one of these records. If you want more information, please get in touch with me. Otherwise, I acknowledge the sponsorship in collaboration with SEPA Resources, Peter Newmeyer and Linda Burnett in particular. And thank you for listening.